Hello. Um, Today I'm going to talk about unit circle. So, unit circle is a special circle which one unit radius, and we can find very special sine and cosine values for different degrees and different radian angles. And also, I will talk about some special triangles and finding their cosine and sine values for 30 degrees, 45 degrees, or 60 degrees. So let's start with the first special triangles. So let me make this bigger. So I have one special triangles, and each side has two sides. So when I divide this special triangle, I will get 30 degree here and 60 degree here. So this side will be 1, this side will be square root of 3, and this side will be 2. So how can I write sine 30 and cosine 30 and also sine of 60 and cosine of 60 from this special triangle? So we know sine, when we are writing sine, we will use opposite side over hypotenuse. For the cosine, we will use adjacent over hypotenuse. So these are our formulas. Keep in mind. So for sine of 30 degree, so I'm looking for here, let's say, what is my opposite side for sine 30? My opposite side is 1. What is my hypotenuse? Is 2. So I find sine 30 for this triangle. And then how about cosine? For cosine, I will use adjacent. What is my adjacent? Is square root of 3. And same hypotenuse is 2. How about sine 60 and cosine 60? So I'm starting thinking this angle. What is my opposite side for this angle? Is square root of 3 over 2. Similarly, what is my adjacent? Is 1 over 2. Okay, so we can do same thing in here. And since they are equal 45 degrees, I can use any of them. Let's say I'm using this one here. What is my sine 45? Opposite side is 1 over hypotenuse is square root of 2. But actually we don't like to see this like that. So we can write it down like square root of 2 over 2. And cosine, same. What is my adjacent? 1 over square root of 2. And same. Square root of 2 over 2. So these are special triangles, and we kind of remember this. And yeah, memorize them. Okay. So we said we will talk about unit circle. when I look at this unit circle, it looks kind of messy, but actually it's so easy to learn. Let me say something about unit circle. In here, I have unit circle, and I put it on the x and y axis. So when I choose this point P and this angle theta, so this point has coordinates which is x and y, but actually they are cosine and sine in this unit circle. How? Let me choose different color. So I'm trying to make right triangle. So this right triangle has three sides. Let's say this side is x value and this side is y value. And this side is 1 because since it is unit circle, it's all of them has a radius 1. So like before we did on the up, when we are using a triangle to calculate sine and cosine, we were saying like sine is opposite side over hypotenuse and cosine adjacent over hypotenuse. In this triangle here, what is my opposite side for this angle theta? It's y, right? And hypotenuse 1. So actually my sine in this triangle, y value. How about cosine? Cosine is adjacent. What is my adjacent? X. And hypotenuse, same 1, is equal x. As before I said, so in this unit circle, x values are cosine, y values are sine. So after that, we can start unit circle. Okay. So unit circle has some degrees. So we are starting from 0, 30, 45, 60, 90, 120, 135, 150, and so on. So how I'm gonna write these in radian? First, let me teach how we are gonna write them in radian. Okay, so let me write first in degree. So we know this is 0 degree, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 30, and again 360. Okay. So we know the whole circle is 2 pi, right? So we are starting from 0 and we are making one spin and come back to the 2 pi. So let's say I divided this circle to the half. So here, since whole circle is 2 pi, this is pi. Let's say I am dividing this whole half circle to the 6 pieces. So when you divide these 6 pieces, equal 6 pieces, should be like that, right? 30, 60, 90, 120, 150, and 180. 6 piece, equal likely, right? So half circle was the pi. So when I divide 6 piece, this piece is pi over 6. This one, 2 pi over 6. And this piece, 3 pi over 6. 4 pi over 6. 1, 2, 1, 2, 3, 4, 5. 5 pi over 6. And 6 pi over 6, actually pi. And we can simplify some of them. Like we can say pi over 3 here. We can say pi over 2 here. And we can say 2 pi over 3. And that's it. Yeah. And we can keep on going, like here, here. So we can keep going to complete the circle. So similarly, we divide 6 pieces actually, the other half part of the circle. So where we left 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, which is 2 pi. So you can simplify here 5 pi over 3. And we can divide here 3 pi over 2. We can simplify here 4 pi over 3. Yeah, I think that's it. Okay. And how about the rest? So let me choose different colors so we can see what I'm gonna do. So like I divide this half piece of the circle to the 6, I'm gonna divide half piece of the circle this time 4 pieces. So whole half circle was pi. So this one is pi over 4. This one is pi over 2 pi over 4. Excuse me. Ooh. So 2 pi over 4, which is pi over 2. And 3 pi over 4. And 4 pi over 4, which is pi. Okay, I can continue the rest. Actually, we don't have to write this here, right, again and again. But to understand it, I am writing again. So I was left in the 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4, actually, which is 2 pi. and this is 3 pi over 2, and we know here pi. Yes, it's easy. When we know the logic behind it, it's easy to write it down. Okay, let's say we know that, and then we want to know sine and cosine values on this unit circle. Let me use a clean circle so we can understand. So I will write it angles again. 30, 45, 60, 90, 120, 135, 150, 180, 225, 240, 270, 300, 315, 360. So we started here to 0 to do 360. Okay, so all of them has over 2, over 2. Let me write over 2's. And I will start from 1, 2, 3. 1, 2, 3. And I will put all of them square root. Yeah, that's it. And similarly, since this quadrant plus plus, this quadrant is 1 minus and plus, this quadrant is minus minus, this quadrant. So I will use this sign for our sine and cosine values signs. Okay, so I will use same numbers here, like this and this same. Only the sign is different. 1 over 2 square root of 3 over 2. The first one negative. Why? Because we are in the second quadrant. Okay, same. This one and this one same. Square root of 2 over 2. Square root of 2 over 2. The first one negative. Similarly here. Well, I don't have to write it like that. I can write 1 over 2. I don't have to use square root for the 1. Okay. Similarly, this one, let me use different color. And this one same. Only difference is signs. Both of them negative. Why? Because we are in the third quadrant. And both of them is negative. Okay, and this one same. Both of them negative. And this one, this top one, same, but signs different. I think you got the logic, right? So here, this one and this one same, but this time first one is positive. So 1 over 2 square root of 3 over 2. And this one is same. First one is positive, and second one is negative. And last, okay, last one. Okay. Okay, so we understand this. So how about here and here and here and here? We know we are in the unit circle. So this is unit circle and 1 radius 1, right? So here my x and y values, x is 1 and y is 0. Similarly here, x 0, y 1, x negative 1, y 0. So for here, x is 0, y is negative 1. Yeah, so we can write unit circle. So why we are going to use this unit circle? Let's say we want to learn sine of 135 and cosine of 135. So I should go 135. Where is my 135? Here. Okay, I'm looking for the numbers here. So sine was the first one, which is negative square root of 2 over 2. And cosine 2 over 2. Yeah, that's easy. Let me see if we forget something. Yeah, I think that's it.